Everybody, in this video we are going to be talking about solving equations, and in particular we're going to be doing solving one-step and multi-step equations, but this is unit 10.1.2. All right, steps to solving equations, and these are not hard and fast rules for solving equations. This is just like general practice of what we do for solving equations. And again, I'm hoping you're seeing that word solve. We're not simplifying expressions. We are solving those equations. We are looking for what our variable actually equals. So here we go. If necessary, we are going to simplify. There's that word simplify versus solve. We are going to simplify the expressions on each side of the equation, including combining like terms. So if need be, and you're going to see some examples today where we simplify on the left-hand side and we simplify on the right-hand side of the equation. And when I say that, I'm talking about the left-hand side of the equal sign, the right-hand side of the equal sign. So we simplify those sides, then we get all variable terms on one side. And I just want to point this out again. If you are not familiar with this, like, what are you talking about side? One side, the other side. We're talking about like if we have 2x plus 3 equals negative 4x plus, 5 minus x. This is referred to as the left-hand side. And I just abbreviate it, left-hand side of the equation. So that's one side of the equation, and the other is the other side of the equation. Or we would say this is the right-hand side. And then we would keep simplifying. So like just even following these rules, we would say, oh, well, let's combine these. We're going to simplify, including combining like terms. So we'd say, okay, there's nothing for us to do on the left-hand side. Let's simplify the right-hand side. So then we would get negative 5x plus 5. Then our next one says get all the variable terms on one side. And it doesn't matter which side. You could do left-hand side or right-hand side. So then we would add the 5x to that side, add the 5x to this side. So that goes away. Then we get 7x equals, I'm going to subtract the 3, equals 2. And now you isolate, this is what we're going to talk about down here. You isolate that variable. You look at, okay, how do I get x all by itself? Well, 7 is being multiplied by x. How do I undo multiplication? I divide. So then my x equals 2/7. And that's how we do that. Then you can always check, and we're going to work on that skill today too, but we check. We take our x and we plug it back in for here and here and here. And we would say, okay, if I plug that in and I get that, do I get the same thing on the left-hand side versus the right-hand side? And you should, like if you simplified this with plugging 2/7 in, and you simplified this with plugging 2/7 in, and you combine it all, the left-hand side should equal the right-hand side if we did everything right. If we didn't, then they won't be equal and we have to figure out our mistake. All right, let me unpause and come back to what we're filling in here. Get all variable terms on one side and all numbers on the other side. Whatever you do to one side of the equation, you have to do to the other. You must also do to the other side of the equation. Then we isolate. There's that word isolate. So we isolate. That is kind of hard to read. It's isolate the variable. What does it mean when you're put in isolation? You're by yourself. That's what you're doing with the variable. You're getting it all by itself using the inverse or opposite operations to undo the equation. To isolate the variable means to solve for the variable or to get it all by itself with a coefficient of 1 on one side of the equation. Then finally, we are going to check your solution by substituting the value of the variable back into the original equation. That's really important to do it back into the original. I've had students before say, oh, I'm just gonna plug it in. It's so easy. I'm just gonna plug it in right here because that's where I've simplified it to. But what happens if we made a mistake right here? Then it's possible that if I plug it in at this stage, it'll make it look like my answer was correct when in fact, I made a mistake up here. And by plugging it in down here, I won't catch my mistakes. That's why you have to plug it in above your mistake. So that way you catch your mistake. Okay, here we go. And by the way, we've got several examples. So we're going to fill up these 2 pages with some examples, and then that'll be the end of this video. So first one, we've got 12.5 minus x equals negative 7.5. And we're going to figure out what our x's are, or what our x is. Lots of different ways. I've had students say, I want to add x to both sides, and I've had students say, I want to add 7.5 to both sides. You can do either way. I'm going to start by adding 7.5 first. So I'm going to add 7.5. I've also had students say, I'm just going to subtract 12.5 from both sides. You could do it that way too. So if we get this, 12.5 plus 7.5 is going to give us positive 20 minus x equals, what do we get over here? We get a big fat 0. Now let's add our x to this side. And we're going to get 20 equals x. And that's our answer. And now we're going to check it. So we're going to check it. We're going to plug it back in. We're going to do 12.5 minus 20. Does that in fact equal negative 7.5? And if I do 12.5 minus 20, guess what? We get negative 7.5. That equals negative 7.5. Check. My check is correct. My check is complete, and that means my answer was correct. Let's do another one. We've got negative 7/2, and that equals x over 10. So many ways to do this problem. Some students will look at this and say, okay, I've got x, it's being divided by 10. How do I undo that division? You multiply. So you multiply both sides by 10. That works perfectly. I've had other students say, well, can't I just cross multiply here? Yes, you absolutely can. Just make sure you put your negative with one of those. So I'm going to show you the cross multiplication way. And I'm going to start with this negative 7 times 10, and that equals 2 times x. And so I get negative 70 equals 2x. Divide both sides by 2. And we get negative 35 equals x. And again, let me back up because I went through this step pretty fast. I divided by 2 because I'm looking between 2 and x, and I'm saying, how do I get x all by itself? Well, that means I got to get rid of this 2. Well, what operation is happening between 2 and x? It's multiplying. How do I undo multiplication? You divide. So divide both sides by 2, and you get negative 35 equals x. All right, now let's check it. So we're going to do negative 7/2. Does that in fact equal negative 35 over 10? Did I do that right? Okay. So let's check. It looks like we can take out a 5 out of both of those. Let's divide by 5. Divide by 5. And then we're going to get negative 7/2 equals, guess what? Negative 7/2. Check. That means this is correct for the fact that that checks out. All right, let's try another one. Number 3, we've got 1/4 y minus 2 equals 3. All right. And again, you can go back up. I haven't really used our steps, but you could have used your steps on any of these. So if necessary, simplify the expressions on each side of the equation. Do I have anything to simplify on this side? No, there's no like terms. Get all the variables on one side and all of the numbers on the other side. Well, let's do that. I'm going to get the numbers on one side, all the constants, right? Constant terms on that side, the variables on the other. So 3 plus 2 is 5. Then our next step says to isolate the variable. Get that y all by itself. How do I undo this? You can divide, or students will tell me, can't I just multiply by 4/1? Yes, because that's going to give us 1, right? That's going to give us a coefficient of 1. Some of you who are like, whoa, whoa, whoa. How that felt like it came out of nowhere. Well, let's look at it. If we go like this, 1/4 y equals 5, and we divide by 1/4, what happens when we divide by a fraction? We keep, we change, we flip. That's exactly what this step is. We kept the first one of 1/4. We changed this division to multiplication. And then we flip this to be 4/1. See, it's not math voodoo, I promise. All right, so if we multiply by 4 on the left, you multiply by 4 on the right. And we're gonna get, because that crosses out, y equals 20. Now run your check. Do your check. Check. So we're going to go back up to the original. 1/4 times 20 minus 2. Does that in fact equal 3? What's 1/4 of 20? It's 5 minus 2. 3 equals 3. Check. Awesome. We're doing good so far, getting them all right. Let's try another one. Let's do 3x plus 5x plus 4 plus 7 equals 88 plus x. Pause the video. You can do this one. Ready, set, go. You should be getting x equals 11 at the end. All right, I'm hoping you're combining like terms. So we can say this is going to be 8x plus 11 equals 88 plus x. I'm going to subtract 11. I'm getting the numbers on one side. I'm getting the variables on the other. So I'm getting rid of the 11. I'm getting rid of that x. And some of you, I get questions on this sometimes like, whoa, how are you doing all those steps in one? You can, or you can just do one at a time. And I'm thinking about how I'm keeping my equal sign here in the middle. And that 11 minus 11 is going to give me 0, right? The x minus x is going to give me 0. So that's perfect. That's exactly what I wanted. And then this 8x, let me get rid of those so they're out of my way. This 8x minus x here is going to give me 7x. 88 minus 11 is going to give me 77. And x equals 11 because you're going to divide both sides by 7 here. So that's exciting. All right, run your check. We're going to have 3 times 11 plus 5 times 11 plus, I'm going to go ahead and write plus 11 because 7 and 4 is 11 equals 88 plus 11. Write a question mark above that. We're checking to see if that is in fact true. So we're going to get 33 plus 55 plus 11 equals, does that equal 99? Well, let's just do one digit. 3, 5, 1, that's 99. Or that's 9, which means the other one's going to be 9, equals 99. Boom. We got that one right. 100%. Batting 1,000 so far. I'm going to skip that one. Let me mark that off, which means this one is now our number 5. All right, so let's do number 5. I crossed off my number 5. We're doing my number 6. All right, so here we go. 3a minus 11 halves equals negative 3a over 2 plus 25 over 2. Okay, here's an option for you. You see that they almost all of them have a common denominator of 2. You can absolutely simplify your like terms. Like you could add the 3a over 2 to this side and add the 11 halves to this side and combine your like terms and keep your denominators. You're going to need to get a common denominator of 2 here and keep going. I'm going to show you a different way, and it's called clear your denominators. Like, let's get rid of our denominators. And so what that means is that we are going to multiply every single term by some number to get rid of our denominator. So what you do, here's how you do that. You look at your numbers here and you say, what's my lowest common denominator or my least common multiple between 1 and 2? And the answer would be 2. So you're going to multiply this by 2, and this by 2, and this by 2, and this by 2. By doing that, we're going to get rid of all of our denominators. It's a pretty slick move. So 3a times 2 is going to give me 6a. Here's what happens. If we multiplied straight across, let me show you this. We would end up getting 22 over 2, which would reduce to what? 11. That's exactly what this numerator is, because this 2 and 2 cancel out. That was the whole reason why we did that step. So we're going to get minus 11. Guess what? The 2's cancel out again, or you would get 6a over 2, which would give us 3a. So we're going to get negative 3a here. The 2's are going to cancel out, or you could do 50 over 2, and that's still going to give you plus 25. That's a slick move, right? So then this problem becomes so much easier. We're going to add the 3a over. I'm going to add the 11, so those cancel out. This cancels out. I'm going to add the 11. So this is a 0, right? That's a 0. Then I'm going to get 9a equals 36. Divide both sides by 9. And a equals 4. And then normally we would go back and check. We're going to drop the checks at this point forward. I wanted to show you what the checks looked like. And you're going to be required to do that in some of your homework tonight in the workbook. But I just wanted to show you some examples, and you can believe me that our answer is actually 4. One alternative to this. So I'm going to give you another alternative to this. Some students are like, I just want to get a common denominator across all of them. And so I'm going to back up to this step. If you wanted to get a common denominator, we could go like this. And instead, our problem would be 6a over 2 minus 11 over 2 equals negative 3a over 2 plus 25 over 2. So if you want to, another way to do this is another pretty easy way to do it, is once you have common denominators across all your terms, you can essentially just look at the numerators and solve. You can go, okay, so that's going to be 6a minus 11 equals negative 3a plus 25. And if you want to do it that way, that's cool too. And you're right at the same step as we are right here. So that's your choice. Okay, let's look at number 6. So number 6 is going to be 4 times 2a plus 3. And then that equals negative 3 times a minus 1 plus 31. And if you want to pause, this one should come out to a equals 2. So you should pause the video, see how you do. Hopefully you get a equals 2. And then I'm going to work through it. So pause the video. So I'm going to choose to distribute first. I'm going to get 8a plus 12 equals negative 3a plus 3, because I'm getting negative times a positive, which gives me a negative. Negative times a negative gives me a positive, and then I'm doing plus 31. Now simplify, combine your like terms, get the a's on one side, the constants on the other, then get a all by itself. Those are our steps. I'm going to go ahead and combine these two. I'm also going to add the 3a over. I'm going to do those two steps. So here I'm getting 11a. I'm going to take this 12 away too, over here. That goes away. Equals, we've got, what is that? 3 and 31 is 34. And then we're taking 34 minus 12 is going to give you 22. And then you're going to divide both sides by 11. And a equals 2. Perfect. We got that one right. Let's try another one. Number 7. Number 7, which is my number 8. All right, here we go. We've got 1/2 x minus 3 equals 2 minus 3/4 x. All right, I want you to try to either get everything with a common denominator right now or eliminate your denominator. So pause the video. That's what I want you to think about. Before you pause the video, think about this. What is your least common denominator between, we've got 2, I'm going to put this over 1, that over 1, and 4. What's your least common denominator, your least common multiple? That is what you're going to multiply every single term by. Ready, set, go. Pause the video. You should be getting x equals 4. Hopefully that's what you're getting. All right. We should be getting, we're going to multiply every term by 4. That's our least common denominator. So then what happens? This becomes a 1. That becomes a 2. So I'm going to get 2x minus 12 equals 8. The 4's cancel, and I get negative 3x. The other way that I showed you up above, let's say we got a common denominator of 4 on all of them, then we would end up multiplying. Again, this is going back. If you chose to get a common denominator for all of them, we'd multiply this by 2 and that by 2. So then we would get 2/4 x minus, we would multiply this by 2 and this by 2. So then we would get minus, oh, I'm sorry, we're getting 4. My bad. Multiply it by 4. So we'd get negative 12 over 4 equals, we're going to multiply this by 4 and that by 4. So then we get equals 8 over 4 minus 3/4 x. You could do it that way too. And then from that point, you're taking just the numerators and you would get 2x minus 12 equals 8 minus 3x, which is exactly what we got at this step. So choose either one of those ways, whether you're getting everything with a common denominator or you're eliminating your denominator. This is the eliminate. Here we go. Now I'm going to add my 3x over. So that's 5x. I'm going to add the 12. This is going to go away. That's going to go away. Here's my equal sign over 20. Divide both sides by 5. And x is going to equal 4 for your answer. Okay. Let's do this next one. This is probably the hardest one on the page. So we've got 1/2 times the quantity of 2 plus a equals 3a plus 4 all over 3 squared. All right, so don't give up on this. I've had students say, when I ask, where do we start? And they're like, I wouldn't, I'd just give up. Don't do that. We can do this. Here we go. Let's distribute first. And then let's evaluate that 3 squared. So what's 1/2 of 2? 1 plus 1/2 a equals 3a plus 4 all over 9. Something I'm going to do here. What I'm going to choose to do is I'm going to split this into 3a over 9 plus 4/9. And I think that'll make it easier for you to see how we do this next step. So we're going to do 1 plus 1/2 a equals, because what this is doing is this is saying take 3a plus 4 and divide it by 9. Well, we can split it and say, well, we're going to take 3a divided by 9, and then we're going to add 4 divided by 9. So we can split it up like that. So now let's look at what our denominators are. I want to put this over 1. We've got 1, 2, and 9. Your choice. I either want you to eliminate the denominators or get a common denominator on all of the terms. So what do you think our least common multiple would be? I think I heard someone say 18, and that would be correct. All right, here we go. We're gonna multiply by 18, or you choose to go like this. We're gonna multiply both the numerator and the denominator by 18. You can do that if you'd like. And sorry, I got distracted because I thought I had a kid calling me, but I do not have a kid calling me. All right, so we're gonna multiply by 18. I'm gonna multiply this by 18, this by 18, and this by 18. So here we go. 18 times 1 is 18. Plus, if we had this, it would be 18 over 2, which would be 9. Or we can go ahead and just cancel 18 over 2 is 9. So that gives us 9a. And then here, let's cross this off. This will be a 1. This will be a 2. So 3a times 2 is 6a. And then here, the 9 and the 18, this becomes a 1, that becomes a 2. And you get plus 8. So now let's combine our like terms. I'm going to subtract the 6a, subtract the 6a, subtract 18, subtract 18. So then here, I'm getting on this left-hand side, I'm getting 3a equals 8 minus 18 is going to give me negative 10. Divide both sides by 3. And a is going to equal negative 10 thirds or negative 3 1/3, like that. And that is our final answer. Now, I want to back up for a second. You are going to have something like this on EdReady, but it actually will stop up here. And this is a common mistake because it doesn't ask you on some of them that look really challenging. It doesn't actually ask you to solve the whole thing. It asks you to figure out what's your least common denominator. It'll stop you right here. And it'll say, what should you multiply all of your terms by to eliminate your denominator? So your answer on this one would be 18. That's what you would type into EdReady for a similar type problem. All right. We've got 3 more. So let's do number 9. Number 9, we've got 1/3 minus 2y over 9 equals 19. If you want, do this one ahead of me. You should get y equals negative 84 for this. And you can go ahead and go for it. Just see on your mark, get set, go. See who can do it faster. So here, if we're eliminating the denominator again, the least common multiple between all of these denominators is going to be 9. So let's multiply this by 9, this by 9, this by 9. So then 1/3 of 9, this first one is going to be 3. The 9 and the 9s will cancel. So I'm going to get minus 2y. And then our 19 times our 9, let me do that. 19 times 9 should give us 171. 9 and 9 is 81. Okay, that looks right. Then we're going to subtract 3 from both sides, and we get negative 2y equals 168. Divide both sides by a negative 2. And y is going to equal exactly what we said, which was negative 84. Super. Number 10. This one is literally kind of a calculator problem. And then I'm going to show you, because some EdReady sometimes asks another question on this type of problem. So you've got 0.4x minus 0.25 equals 1.75. EdReady is going to ask you, what would you multiply to clear your decimals? So what power of 10 could we multiply every single term by to clear our decimals? Well, let's look here. Here we would only need to multiply by 1 power of 10 to move it this way one step, right? Like 0.4 times 10 is 4, but that's not going to help us here. If I multiply this by 10 and this by 10 and this by 10, here I'm going to get 2.5. Here I'm going to get 17.5. So I don't want to do that. So instead, let's look at how many, we've got 2 decimal places here and 2 here. So that would mean if I multiply this by 100 and this by 100 and this by 100, that's going to get me 1, 2. So that's going to get me 40x here minus 1, 2, 25 equals 175. Add the 25. And then we're going to get 40x equals 200. Divide both sides by 40. Can divide them both by 10, and you're going to get 20 over 4, and then keep going, and we're going to get 5 for your final answer. I've had students say, can't I just go from here and add 0.25 to both sides, and then I get 0.4x equals 2, and divide both sides by 0.4? Yes, you can absolutely do that. You'll still get 5, but it won't answer the question of, what do I multiply every term by to clear my decimals? And the answer to that question was 100. All right, last one. And this one is just not too bad. It's a good one to end on. So we've got 1/4 times the quantity of A plus 3 equals 2 minus A. And let's go ahead and solve. So let's first start by distributing here. And so then we're going to get 1/4 A plus 3/4, because again, think about that. We're multiplying it by 3 over 1. So 1 times 3 is 3, 4 times 1 is 4, equals 2 minus A. Again, what is our least common multiple, or our lowest common denominator? It's going to be 4. So I'm going to multiply this by 4, this by 4, this by 4, and this by 4. So then here the 4's cancel out, and I'm going to get A. And then here the 4's are going to cancel out, and I'm going to get 3 equals 8 minus 4A. Then I'm going to subtract my 3, add my 4A, add my 4A. 3's are going to cancel out, 4A's are going to cancel out. So then I'm not sure if it's going to let me write right on the edge. We're going to find out. A plus 4A is 5A. 8 minus 3 is 5. Divide both sides by 5, and A equals 1 for our final answer. Okay, that is it for this video. Thanks for tuning in.